On RT1-5, we're going to work with Pythagorean triples. A Pythagorean triple is any set of three positive integers that work in the Pythagorean formula. So as I'm looking at that definition, there's a few things that jump out at me that I want to be really, really mindful of. The first is that they need to be positive integers. That means I cannot have a negative number, I can't have a decimal, I can't have any irrational number. And it has to work in the Pythagorean formula. If I put it in and they don't work, it's not a Pythagorean triple. So on this slide, I see some common Pythagorean triples. And this is by no means an exhaustive list, but it's ones that are used really, really frequently. And when I'm looking at this, I notice that in each column, I've got some that are really repeating. Really, 3, 4, 5, and 6, 8, 10 are the same Pythagorean triple. I just multiplied by 2, or by 3, or by 4. So once I find one Pythagorean triple, I really have an infinite number of them. So I'm going to work through this and fill in some of those missing numbers. So when I'm looking at that red column, those 3, 4, 5s are a really common one. If I double it, I get 6, 8, and 10. Tripling that, I got 9, 12, 15. On that fourth row, 3 to 12, I multiplied by 4. So I'm going to say 4 times 4, I get 16. 5 times 4 gives me 20. If I want to check my work, I can do 12 squared plus 16 squared and confirm that it does in fact equal 20 squared, and indeed it does. The exact same thing is happening in this second column. 5, 12, 13 is kind of like my base Pythagorean triple. If I double it, I get 10, 24, 26. 5 times 3 gave me 15. 13 times 3 gave me 39. So if I do 12 times 3, I'll get that missing number 36. Similarly, in that last row, I'm multiplying by 4 this time. 13 times 4 gets me to 52. So I can find any number of Pythagorean triples once I know one. This is certainly not all of them. There are many, many more. But once you find one, if you're looking for another, multiplying by any number will give you another Pythagorean triple. Go ahead and pause. I'm going to fill in the rest of these. You fill in as well, and then hit play and check your work against mine. All right, so looking at my work and comparing it to your own, hopefully you've got 14 and 100 missing in that blue column, and 34 and 45 missing in that green column as you are adding on or multiplying that Pythagorean triple. The opposite of the Pythagorean theorem also works. So if the legs of three sides in a triangle satisfy the Pythagorean equation, then the triangle is a right triangle. So it works both directions. If I put it in knowing it's a right triangle and I'm looking for a side, I can find the missing side. And if I want to know if three sides make a right triangle, I can put them into the Pythagorean theorem and figure out, gee, is it a Pythagorean or is it a right triangle or not? We're going to do a few word problems. On this first example, we want to know how high on a building will a 39-foot high ladder touch if the foot of the ladder is 15 feet from the building. So here's what my picture looks like. My building is our variable. We know the foot of the ladder is 15 feet. We can assume that our buildings are well built, that they are made at a 90-degree angle. We're not doing anything crazy with the Leaning Tower of Pisa. And our ladder is 39 feet. Looking at this, I have a right triangle and I'm looking for a leg. So I'm going to put it into my Pythagorean formula. Since x and 15 are my sides, if I square both of those and add them up, they must equal 39 squared. When I square that, x squared plus 225 must equal 1,521, which tells me that x squared must equal 1,296 when I subtract from both sides. And then I just need to take the square root. And because this is a practical geometry question, I only care about my positive solution. So x will be 36 feet. On my second example, I'm asked to find the amount of fencing in linear feet needed for the perimeter of a rectangle lot a rectangular lot with diagonal length 13 and a side length of 12. So I've got my picture and I'm looking for that blue perimeter. I know that the diagonal of the lot is 13, one side is 12. I don't know my missing side, so I put X in. Because it's rectangular, I know this will make a 90-degree angle. So I've got a right triangle right here. And I can use the Pythagorean formula to solve. So I can say 13 squared equals 12 squared plus x squared. And some of you are sitting here and you're saying, Miss Cronin, I've seen these numbers a whole bunch of times. I know that x is going to work out to be 5. And that's why Pythagorean triples are so handy. If you recognize that 12, 13, 5 is a Pythagorean triple, you get a shortcut and you can jump straight in there. If you don't, that's okay. You can still do the math pretty darn quick. And you still get the same answer, so it's a-okay. But if you recognize the Pythagorean triple that's in front of you, it goes a lot faster. I have two sides that are each 12 and two sides that are 5. So my perimeter will be 24 plus 10 or 34 feet. On this next page, I'm asked, are the following numbers Pythagorean triples? And we're actually going to start with this one. This one is super easy because when I look at it, before I even put it into the Pythagorean formula, I know my answer is no. They do not form a Pythagorean triple because this guy is not a whole number. If I have a radical, if I have a square root of anything, if I have a repeating decimal, if I have a decimal at all, I know that it is not going to be a Pythagorean triple. So without even using the Pythagorean formula, I know for sure it's not. When I have this one, the way that I can check to see if it's a Pythagorean triple, if I know their whole numbers and they're positive integers, is I can put them in to the Pythagorean formula and I can say, hey, do these things actually equal each other? So I'm going to do 21 squared and 28 squared and then add them together. And when I do my math, 21 squared is 441, 28 squared is 784. Together, that equals 1,225. Well, 35 squared also equals 1,225. Since those are equal, my answer is yes, these are a Pythagorean triple. On this page, go ahead and pause and do your coloring and then compare to my solutions, okay? Some of these will be really easy because you'll see decimals or you'll see radicals, and others you'll need to actually do the Pythagorean formula. So double check that your work matches mine. You'll notice two of these, this one and this one, were super easy to right away say, nope, not a Pythagorean triple, because you saw a decimal or you saw a radical. The other three that were not Pythagorean triples, you probably had to actually do the Pythagorean formula to double check and make sure that, hey, these don't make a right triangle.